Hello everyone, myself Pranjal Sharma. It is the continuation of my previous topic, units and measurement. Today we will learn on significant figures. Before going to my today's lecture, I have a suggestion for the new viewers. I have made several videos on this topic, so please watch them, then you will understand this video properly. In my lecture on accuracy, precision and errors in measurement, I have explained how the errors are involved in the measurement. Errors means uncertainties exist in the measurement. So every measurement can be expressed in terms of two terms. One is reliable term, and the number one is reliable term, number two is uncertain term. Uncertain term. So if you add these two, then you will get the measured value. So every measured value contain these two quantity. One is reliable term, another is uncertain term. Uncertain term is also known as errors. So in case of significant figures, we will take the reliable term and also the first digit of uncertain term. So reliable term plus first digit of uncertain term. It is called significant figure. Significant figure. So significant figure is defined as the reliable term plus first digit of uncertain term. Let me explain what is significant figures through some examples. Suppose I want to measure time period of a pendulum. The time period of a pendulum, let's say, is 1.65 second. So here 1 and 6 are reliable term and 5 is an uncertain term. So it has 3 significant digit. Suppose I found 1.651 second. I record a value 1.651 second. Here 1 and 6 are reliable, 5 is the uncertainties, and 1 is also uncertain digit. So this term should be neglected. This term should be neglected. So in this way you can calculate significant figures and significant digits. Suppose I want to measure length of an object. Its value is suppose 35.52 centimeter. Here these 3 terms are reliable and 2 is uncertain digit. So in this case these 4 digits are significant. Now we will understand some basic features of significant figures. Major features are number 1, significant figures are independent of any unit system. That means suppose I want to measure some value, suppose 1 kilometer. Suppose I want to measure a length or a distance between two places is 1 kilometer. So it can be expressed as 1000 meter, or so here in this case the significant figure is 1. And in this case also the significant figure is only 1. All these three are insignificant. All these three are insignificant. So significant figures are independent of unit system. Number 2, all non-zero values, all non-zero digits are significant. Suppose I want to measure length, or suppose I want to measure a time period of an object. So 1.54, 1.54. So here 154, all these are significant because these are all non-zero terms. Or suppose I want to measure a length 123 meter. So 1, 2, 3 all are significant. But if I want to measure, I have measured a value I want to measure a value 1, 2, 3, 0. Suppose 1 to 3 meter with a length of an object, then I can express it as 1, 2, 3, 0, 0 centimeter, or 1, 2, 3, 0, 0, 0 millimeter. So in this case these zeros are insignificant. These zeros are insignificant. That means all non-zeros digits should be significant. Okay. Number 3, this is number 2. Okay, this is number 3. Suppose, again I will take the example of the length between two objects is 123 meter. So it can be expressed as 12300 centimeter or 12300 millimeter. Here these two terms are zeros. I have already mentioned that these two terms are insignificant, and these two terms, these zeros are known as trailing zeros because these zeros are came after the digits. So since I have mentioned that these zeros are insignificant, so from this idea we can summarize another feature of significant figures, which is that all trailing zeros in the measured value for having no decimal point are insignificant. Because here no decimal points are, we have not written any kind of decimal points here. So 123 meter, 12300 centimeter, and 123000 millimeter. Here these zeros are trailing zeros, and in that case these are insignificant. Okay. But if you take the consideration of decimal points, suppose I want to measure diameter of a pin. Let it be suppose 0.1200. In that case, these two zeros give the precision of the measurement. So these two values are significant. So from this logic or argument, we can conclude another fact, that all trailing zeros in the measurement after decimal points are significant. The next point is, suppose we measure a value, a value of a physical quantity, which is suppose 0.0025. In that case, this zero is insignificant and these two zeros are also insignificant. These three are not significant. So from this point, from this argument, we can conclude a feature such as that if a number less than 1, then the zeros 0 appear left to the decimal point, and zeros appear right to the decimal point before the non-zero digits are insignificant. So these three terms are, the zero appear left to the decimal point, this is not significant, and zeros appear right to the decimal point, but before the non-zero digits are insignificant. Okay, these are the basic features of significant figures. And also these significant figures, the concept of significant figure is very important in measurement system, but it has numbers of rules and regulations. So to reduce these ambiguities, you can express measured value in terms of scientific notation. That means you can express a value like this way: a into 10 to the power b. So here the reliable terms and there some exponent. Suppose 123 meter, 123 meter can be expressed as 12300 centimeter. Okay, so we know that here these two zeros are insignificant, and in this example only 3 significant digits. That is 1, 2 and 3. So this expression can also be expressed can also be written in terms of scientific notation such that 1.23 into 10 to the power 4 centimeter. Look here, only these 3 terms will be significant. These 3 terms will be significant, and this exponent term will insignificant. So it is useful to write the measured value in terms of scientific notations. It will reduce the errors as well as improving the measured results. I have added all the features of significant figures in concise form along with this video. So pause the video and watch it. Now we will learn on the arithmetic operations associated with significant figures. Arithmetic operations. Rules. Associated with significant figures. Rules. Number 1. Figures. Now rules are rules for multiplication and division. Multiplication and division. In case of multiplication and division, so suppose, let's take an example. Suppose I want to calculate density of a material. Density, mass density can be expressed as density equal to mass per unit volume. Let mass m equal to 4.25 4.255 gram, and volume equal to 2.5 centimeter cube. Then density equal to here 4.255 by 2.5. So its value should be it is 1.702 gram per centimeter cube. The unit is here gram per centimeter cube. But here the significant figures here, in this case the significant figures will be 1.1 and 7. These two terms should be ignored. Why? Because according to the rule of multiplication or division, we will consider that amount of or as many numbers of significant figures as are there in the original numbers with least significant digits. In that case, here the volume contain only two significant digits. Therefore, we need to consider only 1 and 7. Only two significant digits can be considered here. So similar rule can be applicable for division too. Similar rules can be applicable for multiplication too. Now rule for addition and subtraction. Rule for addition and subtraction. Suppose I want to add or subtract some measured values. Let's take an example. Here I want to add three measured value. Suppose one is 1.203, one is 3.25 and another is 1.7. So in that case, if I add all this, then we get 5, 4, 11. 6.153. But in this case, if you observe carefully, then this data have only two significant figures. That means the precision of the measurement in this case is applicable to only this digit. After that, the errors should be present. Therefore, if I want to take all the three values as a significant, then there must exist some error. Therefore, we have to neglect these two terms. That means these two are insignificant. So only this and these two terms are significant. So similar rule applicable for subtraction too. So we can summarize these things as such that, so in case of addition or subtraction, the final result should be expressed as many decimal places as are there in a number with least decimal places. That means here, suppose I want to measure 1.105, 1.25 and 1.5. In this case, so here only two significant digits need to be considered, because the third term here, has only one decimal places after the decimal point. So we need to consider one decimal place after a decimal point in our final result. So similar rule applicable for subtraction 2. Now how we can rounding off uncertain digits. So rounding off uncertain digits. So we often found our results like this. So some parameter, suppose 2, some value like 2.135647. So in this way you can write. So how can you round this value? It is a very essential part while taking the data in experiment. So there are certain rules associated with it. We will understand it through some examples. Suppose I got a value 2.436. So the last term contains 6, which is greater than 5. So in that case, we can round this figure value as 2.44. We will raise this term by 1 if the next term, the last term or next term is greater than 5. If this value is 2.434, in that case we simply dropped it out. In that case our result should be 2.43, but in that case our result should be 2.44. Okay, now if I found a value which is 2.435, now it is neither greater than 5 nor less than 5, but it is equal to 5. So in that case there are two conditions. If the preceding digit is even, in that case, that means the preceding digit means this digit. If it is even, in that case we simply drop that 5 point. That means if I got a value 2.425, then we simply drop that last digit, and our result should be 2.42. But if it is odd, in that case the value should be dropped and the preceding digit should be raised by 1. In that case the result should be 2.44. In this way you can rounding off uncertain digits. I have added the rules regarding rounding of uncertain digits. Pause the video and watch it. So let's rewind what we have learned so far. We have learned what is significant figures and what are the major features associated with it, how we can do arithmetic operations associated with significant figures in case of multiplications or divisions, in case of addition or subtraction. We have also learned on how we can rounding off the uncertain digits. So in this video we have covered all the important aspect of significant figures. So at this point I want to stop this lecture. If you like this kind of content, please like the video. You can share the video, and if you want more this kind of content, please subscribe the channel. Thank you.